Okay. Hi, Stormy. This is Algebra II. We are on page 33, and the date is September 10th. I know that because I got paid for the first time as a teacher today. So today we're doing section 1-5, solving inequalities. And this, to me, feels a little awkward because I'm talking to nobody. Well, I'm talking to Josiah, but it feels awkward. But I think we'll manage. And JJ showed me how to record, so I'm going to make a YouTube channel and hopefully get that to you soon. Oh, and one other message to you, Stormy. Mr. McClanahan says, could you please mail back the SD card I left in your Braille note? So I will email you the address to send it back to him. Okay, start on page 33. Do you know what an inequality is? Hello?
Hi.
Hi. We got one. Give an idea where Ella is?
I do not. I'm sorry, I'm always late at out.
It's fine.
I have to direct people on too much.
Would you be willing to figure that out? If she's coming, it says she's due Monday, Tuesday, Wednesday, Thursday on my Skyward.
Oh,
Ella's gone.
you want me to figure out where Ella is?
Yeah, if you don't mind.
Oh, not a problem.
Otherwise, because if she has technology or mobility, I should probably know.
Oh,
I don't know how to check on Skyward. Yeah. Okay. Sorry for the interruption. Josiah, do you know what inequality means? What do I mean by that?
I can't say.
You don't know?
No.
Okay. Well, it's something like 3 is less than 5. Right?
Yeah.
3 is less than 5, or we can say something like -7 is greater than -9. We can also say something like x is less than or equal to 2, or x is greater than or equal to 2.
Mm-hmm.
She was at a student council meeting. She's coming right down.
Okay. Stormy, we are missing Ella, so I guess we're just going to wait. And actually, well, what?
I'm going to skip.
Oh, no problem. The algebra book is under this. No, it isn't. You must have it. I don't have it. Actually, I'm going to start off with a warm-up problem. I forgot. I had that in the plan. I forgot you were on student council.
I am late.
I forgot. And it was your first student council meeting. So just for your information, we're recording the lesson for Stormy, who isn't here.
Oh, Stormy? Who?
Stormy isn't here.
Oh, she's not.
No.
Right.
Nope.
Oh, okay.
No, I'm wondering if the camera's on. It's a good question. Here's my pen. Okay. So get out a piece of paper and pencil. I'm going to do a warm-up absolute value problem, and I'll repeat what I already said.
Do we only have 2 today?
2.5. Let me know when you're ready with your iPad.
What page are we on?
33. Page 33. Solving inequalities.
Okay, what's it called? Are we doing today?
We're doing lesson 5, or 1-5, and it's solving inequalities. But first we're going to do a warm-up problem from yesterday. Who can tell me what the absolute value of -2 is? 2. What's the absolute value of 5? 5. Okay. So I'm going to give you an absolute value equation to solve, and I want to see what you remember from yesterday. So here it is. Absolute value, x minus 4, close absolute value, equals 10. There was something fancy and tricky we had to do. Who has an answer for me? Go ahead, Josiah. What is it?
It's 14.
That's half, right?
Then you have to make it negative.
Right. That was case 1. He did case 1 where he said x minus 10, or I mean, x minus 4 equals 10. So what's the other case, Ella?
Open up to x minus 4 equals negative.
Okay, when we do this, and I forgot to make this clear yesterday, You don't need the absolute value signs for each case. You're dropping them because these cases take into account both the negative and the positive of the absolute value. So for case 2, then Ella, what's the answer? Oh, yeah, go ahead.
Okay, -6.
Right. Answer is x equals -6. So
I thought you just wanted the one that.
what?
I thought you just wanted the one that worked when you plugged it in back at x.
Oh, they both should work.
Yeah. Oh, they
Yeah.
both would?
I think so.
Sure.
Let's find out. -6 minus 4.
Oh, yeah.
Yeah, because you have to take the absolute value.
Yeah.
You were saying, yeah, so be very careful, because when you check, remember to please plug it into the original equation, not the little one you were doing. Does that make sense?
Yeah.
So I think they both work, and actually that's great of you to remember to check. Beautiful. So that's just a reminder of how to solve these little equations, so we don't forget. Okay, now we're going to start over with section 1-5, solving inequalities. My question for Josiah was, what's an inequality? Do you have a guess, Philip?
So it doesn't equal.
Right. So we say, 2 is less than 5. Or we can say 10 is greater than 1. Or we can say x is less than or equal to 55. So if I say something like x is less than or equal to 55, what do you think the solutions are? Because x is a number, right? And it has to be less than or equal to 55. Well, if that's the case, then your solutions to that simple teeny tiny equation are 55 and anything less than 55, right? Think about it. If say x was 54, is 54 less than or equal to 55? Yeah. If x was 53, will that work?
Yes.
If x is -100, will that work?
Yes.
Yeah. So inequalities are just a way of grouping solutions. It's a way of fixating solutions. So today, we're going to learn how to solve equations like this. So let's read. Who wants to read where it says solve inequalities? We're on 32.
I can read it if you like.
Yep. Big, bold, solving inequalities.
For any two real numbers, a and b, exactly one of the following statements is true. And then I'm going to read the
Yep, keep going.
A is less than b.
Yep, that's right.
So there's a is less than b, a equals b, and a is greater than b.
Right.
This is known as the trichotomy
Yep, trichotomy.
property, or the property of order.
So I generally call it the trichotomy property because there are three things to remember. In the real numbers, and this is where we dissect what exactly the heck was just said. A and B represent any numbers. So in the whole spectrum of numbers, you can have two numbers, one is less than the other, you can have it where they're equal to each other, or you can have it to where they're greater than one another. And this is what we use to solve these equations. It's super important. I mean, we can't have something that's all three at the same time. How can you have something equal to itself and be less than itself, right? That doesn't make any sense. You can't say 5 equals 5, but also 5 is less than 5. No. So that's why they have these three options. This one, or this one. So less than, greater than, or equal. And then, Ellie, you want to read where it says adding the same? It's right below the big old.
Adding the same number 2 or subtracting the same number from each side of an inequality does not change the truth of the inequality.
Right. So I want you all to look at the box right below it. It says key concepts and see what on earth they're talking about while I blurb on and on. So say we had 2 is less than 3. This is just what we're given. is 2 plus 1 less than 3 plus 1? Yeah, because 2 plus 1 is 3, 3 plus 1 is 4. So yeah, okay, of course, 3 is less than 4. And we can also go the other way. Is 3 plus 1 greater than 2 plus 1? Sure, 4 is definitely greater than 3. And it also works the same way if you subtract numbers from what you're given. Like, is 1 minus 1 less than, or hold on, is 1 minus 1 less than 2 minus 1? Yeah, 0 is less than 1, and so on. So what they're trying to tell you is when you solve these equations, you know how we add and subtract things from both sides? It won't change anything. This trichotomy still holds. And we're going to practice this in a minute. It looks like we're going to do it. So below the box, there's a paragraph. Go ahead. Chris, do you want to read?
Sure. Where it says these properties.
You got it.
These properties can be used to solve inequalities. The solution sets of inequalities in one variable can then be graphed on number lines. Use a circle with an arrow to the left for less than and an arrow to the right for greater than. Use a dot with an arrow to the left for less than or equal to, less than and equal to, and an arrow to the right for greater than or equal to.
So this is something I'm just going to talk about because I know you all know how to graph numbers on a number line, right? You just fill it in. But with, like I said earlier, x is less than or equal to 50, I believe it was. The way you solve that is, remember we said 54 works, 53 works, 52 works. So on the number line, since it's less than or equal to, you put a closed dot above 50. And then you put a solid line all the way to the left, as far as your pen will go, to indicate that all the numbers to the left, 50, can be x. Now if I said x is greater than or equal to 50, you would then put a closed dot still above 50, but the solid line of numbers you could use are anything bigger than 50. And so the open dot versus the closed dot will tell you whether or not you include, the number you start with. For instance, x is less than 50. If that was an equation, that indicates that x is not 50. You can't have x being 50 because it doesn't say less than or equal to. So in that case, you would put an open dot. Does that make sense? It's just a way of visualizing the number line and solutions to these equations. All right, we're going to try and solve one of these using the adding and subtracting property we just learned. So Josiah, you want to read example 1?
Yes.
The first part before it starts solving it for you.
Wait, which part?
Just the problem. Don't start reading the steps yet.
7x minus 5 is greater than 6x plus 4.
And then,
Graph.
right,
Solution set on number line.
right, which I'm not going to have you do because you guys are smart and I know you know how to do it. So this is typical of an inequality that you're going to get. And it's just like the two-step equations we're used to doing, except there's a greater than sign in the middle instead of an equal sign. But remember, if you add or subtract a number, nothing happens. Like, it's still the same in the trichotomy. Greater than will stay greater than. Does that make sense? So when you solve this crazy thing, you can still add and subtract and not switch the sign. Anyway, you'll see in a second. So what do we do to solve this thing first? And we can read through the book. Well, they decided they were going to subtract 6x from both sides. And that gave them, well, they did it and wrote it out for you all pretty. And then on the left, 7x minus 6x is x. And on the right, 6x minus 6x is 0x, which is 0. And then they also did the numbers at the same time. They did, well, it looks like they added, it looks like they did the 4. And so they added 5 to both sides, I think. I can't tell.
Yes.
Yeah. And so then they got x minus 5 is greater than. I keep wanting to say equals because we're so used to it, right? X minus 5 is greater than 4. and then they added the 5. Okay, yeah, duh. I was looking ahead. And then you get x is greater than 9. What is, Josiah, what do I mean when I say x is greater than 9? What's the solution in words?
Any number larger than 9.
Right, and I'm glad you didn't say equal to 9. Right. And that's absolutely. And then they give it to you if you want to take a gander at the number line. They left an open circle above 9 because it's not equal to 9, and then they bolded the number line into the right. Whew, that's a lot of stuff. And of course, check your solution. You plug 9 into the original equation. 7 times 9, 63. Minus 5, 58. Is 58 greater than 54 plus 58? Okay. Somebody want to do the math for me? 7 times 6 or 9 is 63.
Yeah.
Minus 5, 58. 6 times 9 is 54. Plus 4 is 58. Huh. So they check their answer, and then the inequality should be true. Okay. I thought I got 58 is greater than 58. What did you guys get when you checked it?
That does make sense because that would mean that it is not true. That's why there's an open circle on mine.
No, the open circle just means we're not including none. Oh, yeah. Huh. Okay, sorry, we're supposed to use, okay, to check these, thank you, Chris, so great. To check these, you don't use 9, you use anything bigger than 9. So you could use 10. Duh. See, I've got the after lunch sleepies too, right? So, okay, let's do this. 70, because I use 10, it's nice and easy. Minus 5, 65 is greater than 64. Heck yeah. Okay, check. All right, we're going to start to the right again. Josiah, you want to read this big old paragraph that says multiplying?
Which one?
There's a paragraph right below check.
Yeah. Multiplying or dividing each side of an inequality by a positive number does not change the truth of the inequality. However, multiplying or dividing each side of an inequality by a negative number requires that the order of the inequality be reversed. For example, to reverse greater than or equal to, replace it with a less than or equal to.
Right, or you have it backwards. That's a less than or equal to
Oh, sorry.
replaced by greater than or equal to. And actually, the way I think about it, and this works for Braille users too, is the little pointy part, since it's smaller than the big part, I think less than. So since smaller comes first, it's less than. And then in the right one, since the big mouth part comes first, then it's greater than. That's how I think about it. And in Braille, the 2 dots come before the 1 dot, and the 1 dot comes before the 2 dots. Same concept. And they demonstrate to you this in the key concepts box, and I'll talk about it. So if I said 2 is less than 3, apparently my favorite example, is 2 times 2 less than 3 times 3? Yeah, 4 is less than 9. What if I use it again? 2 is less than 3. What if I said is negative 2 times 3 less than negative 2? Or, excuse me, and negative 2 times 2 less than negative 2 times 3. What happens when we do that?
It's reversed.
Right, well, that would mean negative 4 is less than negative 9. Is that right? No. And so, because of that, whenever you multiply or divide in an inequality equation by a negative number, you flop the sign around. Because, if you think about it, negative 4 is less than negative 9. Okay, that doesn't make any sense. But if we flop it and say negative 9 is is less than negative 4, we got it. And they show it to you in this box if you want to take a quick look at it. On the right side, they do it for you. Hey, they did negative 2 and 3. Neat book. Stealing my examples. And then they tell it to you in words. So, Ella, you want to read at the very bottom of the page where it says the solution set? And we're going to talk about this. very bottom of the page below that big box, it says division property. Because it's the same for division. So that's why I'm not repeating.
Oh, there's a division property.
Below it, there's a little paragraph, 2 sentences below it, where it starts with the solution.
Oh, okay. The solution set of an inequality can be expressed by using set builder notation. I don't know.
I'll tell you in a minute. And it gives you an example.
For example, the solution set in example 1 can be expressed as.
All right, here we go. I'll read this part since it's math notation. That's a brace. And in Braille, a brace is 4/6 left paren to open and a 4/6 right paren to close. And what this says is open brace, X, vertical bar, X is greater than 9, close brace. And in math, that vertical line means such that. So what we mean by that is all x's such that x is greater than 9. Now, for this class, I'm not too, I'll let you pick, because in a second we're going to figure out another way to write solutions to these. So if you were, x is greater than 9, sure. But if you want to be very proper and mathematical about it, open brace, x, vertical bar, x greater than 9, close brace. And that's called set notation. Anything sitting in braces is called a set. That'll come later. So if we turn to the next page, or in print, look over to the next page, we're going to go to example 2, and we're solving an inequality using multiplication or division. Ellen, do you want to read the first line of the example? Ooh, that's more.
Solve negative 0.25 y greater than or equal to 2.
And then it says, graph on the number line. And give the solution set. Okay? So, all right, typical equation. What would we do in this case? How do we get y all by itself? If we have
Divide by the 0.25.
Yeah, it's not 0.25. What is it?
Oh, 0.25, negative 0.
Ah, so what happens because we're dividing by a negative number?
And positive.
Nope. And let's look at the example and it'll make it clearer to you. Negative 0.25y is greater than or equal to 2. And so they did it for you. They wrote it out. Negative 0.25y over negative 0.25 is less than or equal to 2 over negative 0.25. Because remember, if you divide by a negative number, the inequality won't make any sense anymore. Like he said, it's reversed. So because it reverses it, we also have to reverse the sign. That make sense? And you can try a few practice ones if you want. Like if we had negative 2y is greater than or equal to 4. Okay? Negative 2y is greater than or equal to 4. Okay, so we have to divide by a negative 2, which means we'd have to switch it around. So we got y is greater than or equal to negative 2. Okay, that doesn't make any sense. So we have to flip the sign around and say y is less than or equal to negative 2. Anyway, does anybody have any questions about this part? Why are we flopping the sign? Yes, no, maybe? I take that as a no. Because if you don't ask, I won't know if you need the help. Okay? Just in general. So our answer is y is less than or equal to negative 8, according to this thing. And then they wrote it out in set builder notation. And remember, that's just open brace, y, vertical bar. Y is less than or equal to negative 8, close brace. Now we can always check what happens if we plug in. So this time, since there's a less than or equal sign, we can actually plug in negative 8. So Sonia can be smart. Negative 8 The fourth, that's, hold on, 1/2 is greater than or equal to 2, or is less than or equal to 2. Is 1/2 less than or equal to 2? Yes, so it works. How do you feel? Good. So the key here is just to remember that when you're dividing or multiplying by negative numbers, switch your sign in the opposite direction. Car? Thank you. Whew. Everybody need like a little brain break? Chris, you want to read this paragraph below the number line?
The solution?
Yep.
The solution set of an inequality can also be described by using interval notation.
And this is my favorite.
The infinity symbol, which is a plus and an infinity sign, and negative infinity are used to indicate that a set is unbounded in the positive or negative direction, respectively. To indicate that an endpoint is not included in the set, a parentheses, paren, close paren, is used.
Right. So, infinity, unbounded. It goes on forever. If you started counting all the numbers, you wouldn't get to the end of them before the end of your lifetime. Numbers go on forever. Just like x is greater than 9, all the numbers past 9 go on forever. Those are all the solutions to this problem, to that particular problem. And I like interval notation much better because it really helps you see how far or what your boundaries are to your solution. And we're gonna do a little work with this. So it says a bracket is used to indicate that the endpoint, -2, is included in the solution set below. Parentheses are always used with the symbols negative infinity or positive infinity and negative infinity because they do not include endpoints. Well, right. Infinity goes on forever, so you can't say it's included. Infinity is kind of an abstract concept, huh? Oh, and by the way, in Braille, it's .4 and then everything, as in .4 and then 1, 2, 3, 4, 5, 6. That's how I remember infinity, because it's all the dots. Okay.
I have a question. I'm sorry.
Now,
I don't understand the parentheses if they come after a number. If there's a number, isn't that the end of it?
well, and I think it will make more sense if we do an example, because I know all of you probably have that same question. So let's look down here at example 3. Josiah, you want to read the problem?
Yes. Okay, solve -m is less than or equal to m plus 4 all over 9, and then graph the solution on set on a number line.
Okay. All right. Whew. All right, we got a less than or equal sign. Okay, great. That means whatever we get, we have to include. Okay. So when I see a less than or equal to sign, in set notation, I always think, oh, that's a bracket. So I'll talk about it in a second. It's just notation. It's a code. It's nothing scary. But the first thing we got to do is get rid of what? This 9 hanging out here. So what we do is multiply each side by 9. And -1 times 9 is 9. So we got -9n equals m plus 4. I said it again, so you're going to have to catch me. Is less than or equal to m plus 4. And then we have a 4 hanging out by this m, so we have to get rid of that. Oh, actually, they subtracted this m. So what's -9m minus m? Team Algebra 2.
Wait, which one?
I'm looking at -9m is less than or equal to m plus 4.
Oh, okay.
So how do we get rid of that m? What happened?
You divide that from 9.
Nope. We got a -9m on the left and an m on the right. How do we combine those like terms?
You divide the m on the right side?
Nope, they're just like terms. So if we have a -9 and a 1, what would we do? Okay. Do you have an idea, Ella?
Wait, to get the m by itself.
Yeah.
I don't know the exact thing. You have to cancel out the negative 10 by
Oh, the one above that.
oh, negative 10. 9m.
Yeah, the more it says negative 9m is less than or equal to m plus 4.
Oh, you move the m.
Right. How do we move the m over? How do we move a positive m over to the other side?
You make it negative.
Right. You subtract m from both sides. Does that make sense? Because they're like terms. There's no division here. It's just adding and subtracting. So what's negative 9m minus m?
Negative 10.
Right. Negative 10n. And then what's on the other side of the less than or equal sign still? Okay. And here's the golden question. What's next? Since we have a negative 10 times m is less than or equal to 4.
You divide the negative 10.
Right. And when we're working in inequalities, what does that mean right off the bat in your head?
The signs.
Yeah, because you're dividing by a negative number, so we got to flop the sign. So now we just get m is greater than or equal to negative 4 over 10. Ew. Oh, is that it? No. Oh, negative 4 over 10. We're not quite done yet. Anybody see anything to do with that fraction? All right. What does it become?
2/5.
You forgot the negative.
Negative.
Never forget the negative. Okay. So, and I'm going to talk you through this set notation thing. Okay. M is greater than or equal to negative 2/5. So if you look in your book right below that and above the number line, it says the solution is, and they put it in set notation. So if it's greater than or equal to, are we going in a positive or a negative direction? If everything is, if x is greater than or equal to negative 2/5. Right. So one of your bounds, for a better word, is positive infinity. And remember what I said earlier about how you never include it. Okay? You never include positive infinity. So that's why there's a parenthesis next to it. And that's just math notation. Any number you do not include, you put a parenthesis next to it. But where does it begin if m is greater than or equal to negative 2/5?
Negative 2/5.
Right. And because negative 2/5 is one of our solutions, they stuck a bracket next to it. So bracket just means you include the number. Parentheses means you don't include the number. You include everything up to that number. So in interval notation, it's bracket, because we include negative 2/5, comma, positive infinity, because we're going in a positive infinity direction, close parenthesis, because we don't include it. Whew. Does that answer your question, Chris?
Yes, thank you.
And that's why it's just notation. It's just a code. It's just, it'll have to be something you learn to recognize. Boy, I think my brain hurts a little bit. We're going to skip example 4. So go ahead and turn to the homework on page 37. And I want to see your answers this time. And I always say that, but I really do mean it. And I am having you complete 4 through 10 even and 15 and 16. 4 through 10 even, 15 and 16. Oh, I turned too many pages. Okay. Okay, Stormy, that's all I have for you today. See if I can stop this, and I will try and send it to you by the end of the day, but I have to create a YouTube channel first. So I don't know if I can do that on campus, because it's probably one of those quota time things. So please let me know if you have any questions.